This is question 6 of the Leaving Cert Ordinary Level Paper 2 in 2021. As always, if you want a copy of the set of notes I'm working off, just send me an email to shanetroy@gmail.com, and that email address will be in the description below. And if you like this video, just click subscribe to get access to more playlists. So question 6 here looks like a geometry question, and we have A part 1. So on the diagram below, showing the triangle ABC, so this is triangle A, then B to C. Okay, so I get what's going on here. Construct the perpendicular bisector of the side AC. So that's this side here. Okay. Show all your construction lines and arcs clearly. So this is a fairly standard construction. Now, sometimes this is given just as a line on its own, not at this kind of orientation. But I suppose one simple way to do it would be to take your compass and measure probably more than halfway, and you can make an arc here and here. And then take the compass point of the same length and place it here. You do an arc like whatever. Okay, no, probably like that actually, now that I think about it. And that's not quite to scale there. But as long as you join this point here to this point here, okay, you're going to end up with a line. No, apologies, my lines are terrible. I'm not using a ruler here, and it's just hard to draw them. Okay, so I'm going to go straight on to the next page here. Okay, so you can see there just I kind of put in, there's a GIF here playing in the background, but you can see there they've taken the compass length. You can usually see more than halfway. And then draw an arc here and an arc here, and then put the compass point to the far side and draw the arc, and then draw a straight line through. So it's fairly handy once you know how to do it, but that's the thing with constructions. They're great when you know what to do, not so great if you don't know what to do. Okay, and that's it. Okay, so now part 2 then, I'm going to go to the next page, actually to the construction here. It says construct the circumcircle. Okay, that's a circle going around touching all 3 points of the actual triangle itself. And as always, show all your construction lines and arcs clearly. So just sometimes people do the markings they make, they rub out to try and make it look neater. That's sometimes, I think, something from technical graphics. You know, the students kind of just want to get, because that's something you would do in that subject. But the marks, sometimes they are what get you the marks, if you get me. So question 6-8, part 2, we have it here. Now you've already got a perpendicular bisector drawn on the diagram. Okay, you're going to do the exact same from one other side. So this other line here is bisecting the line AB. They could do it for BC as well, and then all 3 points would meet here in the center. Okay, once you then have your compass point, place it here, bring it to any of the sides of the triangle, and you can draw the circle. You'll get the circumcircle. And that's it. Okay, and in the notes here, there's a web link to a load of different sources where they go through kind of all the constructions. But there's only a certain amount that are on the Leaving Cert that you need to be aware of. If you're kind of completely stuck, try aim for 3 to 5 marks by just doing something. You never know. You might get a Hail Mary pass and get the 5 marks, but realistically, you'll probably get 3 marks by doing something relevant. Okay, and that's question 6, part A. So then in question 6, part B, okay, there's 2 parts here, and this is a scale factor question. It says here the triangle PQR, so that's here we are, PQR, is the image of the triangle DEF. That's over here. And I can see here they give me one side here. If it's an image, this is basically enlarged. Okay, so the triangle PQR is an enlargement of DEF. And it says that here, sorry, under an enlargement, the diagram is not drawn to scale. The scale factor of the enlargement is K is 2.5. And then they tell you that the EF there on the smaller triangle is 3. So the part 1 here says use the scale factor to find the length of QR. Now, in a sense, there's only so much you can do here. And if I was kind of BSing this, I might go 3 times 2.5, because if you see here, like 3 and whatever this is are related, and the scale factor is what's changing that. Now, I might want to go and try divide them. Now, if I divide them, that's going to be a little over 1 point something, okay? Whereas this, 3 by 2.5 is going to be what? 7.5. Okay. Now it's centimeters. This is the scale is centimeters. Now, which one makes more sense? That the side here, QR, is smaller or bigger than 3? To my mind, it's obvious that it's bigger. So therefore, this is the strategy that was correct. Now, ideally, you'd know. You multiply something by its scale factor, you get the enlargement size. That's kind of a standard method of doing it there. Now, in the second part here, this is the area of the triangle PQR is 18.75 centimeters. Okay, so that's this triangle here. They're talking about the area of that. Okay. Now, it says find the area of the triangle. Now, there is a formula for this that we could use. That's one you kind of have to memorize because it's not given in the maths tables. And that's the formula that I suppose the area of PQR, this is the bigger triangle, is equal to the area of DEF, the smaller triangle, times K squared. Now, basically, what we can do here is rearrange. Okay, so I can, if I want to get rid of the K squared here, so I want the area of DEF, that's what I'm looking for. I have the area of PQR, the 18.75. I have the scale factor, that's 2.5. So this is an equation of one unknown. Okay, so it's solvable. If I want to get rid of the K squared and leave the DEF, I could divide everything there by K squared. That's going to cancel them. If I do so to one side, I have to do it to the far side. So once I've done that, okay, that stuff there goes away, that gets cancelled. You're left with this kind of sum here. Now, the area of PQR is, okay, 18.75. The area of the K is 2.5. Now, that's a calculation that can go into the calculator. Now, I have it done here on the next page. And 18.75 divided by 2.5 squared gives you an answer of 3 centimeters squared. And that's the area of DEF. So for both those parts, if you know the formulas or have an awareness of it, especially the second one, it makes it easy. Now, the first one you could probably guess by just trial and error and just looking at the common sense of it. Part 2 is a bit harder. If you don't know this formula, you're probably going to be wishing and waffling around trying to get to an answer. Anyway, that's question 6, part B. So that's it. Okay, I thought it was longer. So see you on question 7. If you want to copy the set notes I'm working off, just send me an email at shanetroy@gmail.com. And if you like this video, just click subscribe to get access to more playlists. Okay, best of luck.